Hello everyone, in this lesson we will be introduced to integrals. Now before we jump into formulas, let's understand the idea behind integrals. If you have a curve on a graph like this one and you want to know the area that lies underneath it. So how will we do this? We will do this by adding very small pieces of area. Now from where will we get these pieces of area? We will divide the space underneath the curve into very small rectangles having width dx. Now the width here of each rectangle is dx. So dx, width dx, dx. The height will be f of x, so f of x0, the height of the first rectangle, f of x1, the height of the second, and so on. Now, all the rectangles have width dx and length f of x. Now, f of x dx is the area of each rectangle. So area of each rectangle is f of x height dx width, or f of x length dx width. Now the total area will be the sum of all f of x dx. So now once we understand the concept, we will see how mathematics gives us a clear formula to calculate it. Let's recall some derivatives, since derivatives are strongly related to integrals. Now, what is the derivative of x power 2? Easy, the derivative is 2x. So this is the derivative of x power 2. Now what is the derivative of x power 3? The derivative is 3x power 2. Sine x prime, or the derivative of sine x, is cosine x. Now you are familiar with the derivative, but what if we ask the question in a different way? Now, what function has derivative 2x? What function has derivative 3x power 2? The answer here will be this x power 2. Here it is x power 3. So we call x power 2 and x power 3 the primitives. So the primitive is the opposite of the derivative. The primitives of 2x and 3x power 2. Also, cosine x is, also sine x is the primitive of cosine x. Now this is the idea of primitives. Now let's look at the formal definition. A function f capital is called a primitive function of f if f prime of x is equal to f of x, like the examples we have seen. Again, x power 2 prime is equal to 2x, so x power 2 is the primitive or a primitive we will see why a primitive later is a primitive of 2x. In other words, f is a function whose derivative gives us f. Now if I is an interval subset in R, non-empty open interval, and the two functions capital F small f are defined continuous functions satisfying f prime capital equals to f over I, we call then f a primitive function of f over I. The title here is why do we add plus c. Now during the explanation you will understand the title. Now x squared is a primitive of 2x. Okay, what about x squared plus 5? Let's find its derivative. Derivative is also 2x. So x squared plus 5 is also a primitive of 2x. In order to generalize, we will say that, so we will say x squared plus c are the primitives of 2x. Now another example, 3 is the derivative of 3x, so 3x is a primitive of 3. Also the derivative of 3x plus 2, let's say, is 3, means 3x is a primitive of 3x plus 2. In general, 3x plus c are the primitives of 3. Now instead of saying primitives all the time, we will use the symbol integral. This symbol is called integral, so we will write integral 2x dx, and remember this is an area with length 2x and width dx is equal to x squared plus c. Integral 3 dx is equal to 3x plus c, and so on. So this is what do we mean by, or what do we meant by the title, why do we add c? We add c to all primitives in order to generalize, because a derivative has more than one primitive. Properties of integrals. Integrals have some properties. For example, integral of a sum or difference. The integral of the sum of two functions will be equal to the sum of the integrals of these two functions. So when you have two functions added together inside the integral, you can integrate each one separately. Integrals distribute over addition, subtraction, just like derivatives do. So instead of doing big complicated integral, you can break it into small ones. Example, integral of 3x squared plus or minus 4x dx. Plus or minus means it works in both cases. If the functions are added or subtracted, it will be equal to the integral of 3x squared alone plus or minus the integral of 4x dx. We can split these two integrals and integrate each term alone. This will give you 3x cubed over 3, which is the integral of 3x power 2. X power 2 integral is x cubed over 3. And the integral of 4x is 4x squared over 2. So this will give you 3x cubed over 3 plus or minus 4x squared over 2. And don't forget to add c. So we treat each part separately and then add the results. Property 2, factoring constants. Integral c f of x dx, where c is a constant, is equal to c integral f of x dx, where c is any real number. So as with limits, derivatives and indefinite integrals, we can factor out a constant. So this tells us that constants can be pulled out of the integral. This is the same idea we used in derivatives. Constants do not affect the shape of the curve, they only scale the area. Example, integral 2x squared dx is equal to 2 outside the integral, then integral x squared dx. Now integral x squared dx is x cubed over 3 sure plus the constant c.